All right, thank you so much for joining us today. So in this video, we are going to look at constant base function and non-constant base function, and then we are going to combine examples on whatever we've learned from the previous videos, and then we try our hands on it. So we have examples that we are going to try, and then we have examples that I'm going to give you to try and leave your answer in the comment section for me to check it out for you. So let's talk about constant base function. So we are assuming that I have y is equal to a to the power x. We learned an exponential function where y was equal to e to the power x, and we saw that for us to differentiate this, we find the idea that we need to differentiate what is on the top, and then we multiply it by the function. So that's what we learned from an exponential function. And we see that this is kind of like in the form of the exponential function, but the only thing is now this is the e and this is a. So there is something small that is going to change with this constant base function here. So y prime here is going to be the same thing, differentiate what is on the top, what is x, times, now we maintain the function as we've done here, but I'm going to modify this by multiplying this by length of the base. So that's what we are doing here. I just multiply this one by length of the base. Why? Because here, when I multiply it by length of the base, we know that this is going to give us 1. So we didn't even see that, okay, we need to do that. So there was no need for us to add length of the base to it because this is going to give us 1 always. But here's the case that since this is a and it's not e, this is not going to give us 1. So it means that this is what we are going to get whenever we are differentiating a constant base function, when the function is not, when the base is not e, that is the exponential function. So when I do that, then this is going to give me something like, when I differentiate this, I'm going to have 1 times this times length of a, and this is going to give us ax length a. So that is how we differentiate a constant base function. Differentiate the top times the function and take length of the base. So that is how we differentiate a constant base function. Right. Let's look at non-constant base function. So non-constant base function is kind of like, you remember the power rule, right? Where we have x is to the power n, where the n here is constant. Now this is a non-constant base, and then the top 2 is a non-constant function. So this is kind of like this is constant, but this one is also a function of x. So we cannot use the idea of the power rule to do that. So we need to have a way of doing it. So let's see how we can successfully go through this. So anytime I have a function like this which has non-constant base, like the base is not constant, as compared to this, we have the x here, but the base here is constant, then what we need to do is we need to make sure that for us to differentiate, this x comes down. For us to bring this one down here, then we need to pick the natural log, right? So this is going to be, let's pick natural log on both sides. So this is what I'm going to have. And when I do that, I'm going to have the natural log of y to be x length of x. So this helps us to write the function in 2 forms so that we can use the product rule. So as soon as I do something like this, then now I can go through the process of doing differentiation. So let's go through. Now we know how to differentiate a natural log function, and we are saying that for me to differentiate the natural log function, let me put this one into parentheses so that we can use the terms that we were talking about. Good. So we are saying that 1 divided by what is inside the parentheses times the derivative of what is inside the parentheses, right? So that's what we learn. And this is going to give us, now this is kind of the product rule, right? So if I pick my a to be x and my b to be length of x, then what am I going to get for a prime? When I differentiate x, I get 1. And when I differentiate a b, I'm going to have 1 over x, as we learned that when I differentiate a length of x, I get 1 because I'll multiply it by the derivative of what is inside the parentheses, and it's just going to give me 1. So what do we need to do? For the product rule, we need to multiply this to this and then this to that. So I'm going to have x times 1 over x plus 1 times the natural log of x, right? So this is what I'm going to get. Let's simplify. 1 divided by y. Now the y over the x is the same as y prime. So now when I do this, this is going to give me 1 plus the natural log of x. And we are looking for y prime. That's what we are looking for. So what I'm going to do is I'm going to multiply this one by y and multiply this one too by y. So I'm going to have y prime to be equal to 1 plus the natural log of x times y. But anytime you are dealing with, explicit, the final result should be in terms of x. So we need to go and look for y. What is y? Y was giving us x to the power x, and our y prime is going to give us 1 plus the natural log of x or times x to the power x. So this is what we are going to get at the end of differentiating it. So with the non-constant base function, this is how we need to go through the process. So anytime I have some function like this, I need to pick len on both sides and then bring the exponent here down. Then now I go through the differentiation that we've learned, right? So basically that's what we need to do with non-constant base function. So now that we know the base, constant base and non-constant base, let's take example and combine, everything that we've learned from the previous video in addition to what we just learned, and then let's solve some example, right? And I give you some example for you to also try as well. So here, this is constant base, right? So what will be f prime? Now, since we have f of x is equal to 2 to the power x, then f prime is equal to, so what do? We said differentiate the top. So I differentiate the top, which is x, times maintain the function, then I multiply it by the length of the base. So don't forget the base is 2 and this is the exponent. So when I differentiate x, I get 1 times 2x times length 2, and this is going to give us 2x, the natural log of 2. You see that it's very simple, right? So as we are doing, we are trying to put all the things together in a way that it will help us to understand each function, how to differentiate it, so that anytime you see a derivative question, you don't panic, right? Because you know the general rule. Oh, I'm using the product rule, I'm using the quotient rule. Then we go through the process. Now let's look at this one. So I see that this is like kind of exponential, but the base is in terms of x, and then the power 2 is in terms of x. So we need to use non-constant base procedure to solve. So this one, I will let gen of x to be equal to y, or y to be equal to gen of x, and I'm going to have y to be equal to tan of x, or to the power x to the power 3. So remember the procedure, we need to take the natural log. So natural log on both sides, we are going to have tan x to the power x to the power 3, so that this one will help us to bring down the exponent, which is going to give us x cubed natural log of, so let me put this one in parentheses. So this is going to give us tan x. Now, you see, whilst you are learning, you need to be paying attention to some of the terms. Anytime I differentiate len y with respect to y, you will see that I'm going to have something like 1 divided by y times y prime, as we learned from here. So when we differentiated this, we have something like this: 1 divided by what is inside the parentheses times differentiate what is inside the parentheses. Then this one. So one thing that you need to also learn from this is, anytime you are dealing with non-constant base, it's kind of because you are picking the natural log and this one is coming down, you are always almost like you are going to get the product rule, unless maybe this here is a fraction. That's where you are going to get a quotient rule. So anytime you are dealing with non-constant base, it's either you get the product rule or you get what? A quotient rule whenever you are solving it. So you need to pay attention to that one too as well. So let me use the product rule. Since this is product rule, I'll pick my a. Let me pick my a to be x to the power 3 for this one, and my b to be this, which is the natural log of tan of x. So what is a prime? Using the power rule, we are going to have 3x squared. And then what is b prime? We know how to differentiate a length function. So 1 divided by what is inside the parenthesis times the derivative of what is inside the parenthesis, right? So this is going to give us sec squared x. So this is the same as sec squared x divided by tan x. So that's what we are going to get. All right, so if that's the case, then what can we do again? We know product rule. Multiply this one by this and multiply this one by this. And then you are done. So let's do that. We are going to have something like 3x squared natural log of tan x plus, then I multiply this one to this. So I'm going to have x to the power 3 sec squared x divided by tan x. So this is what I'm going to get. So now when I'm done, I need to make y prime the subject. So I'm going to multiply this one by y and the whole of this 2 by y. So I'm going to have y prime to be equal to 3x squared natural log of tan x plus x to the power 3 sec squared x divided by tan x, all times y. So finally, this is what I'm going to get. Y prime is equal to x squared natural log of tan x, right, plus x cubed sec squared x divided by tan x times what is y? So always we need to go and look for y. Y is equal to this. So we are going to have times tan x all to the power x to the power 3. So this is how we go through the process of finding non-constant base, and when we are talking about constant base. Let's take more example to practice, right? Using some of the idea from the previous video. All right, so this is a product rule. We know that. So let's pick our a times b. So let's assume that a is equal to 5 to the power x, right? And let's assume that b is equal to sine 2x. So we know that a prime, we need to use the constant base to solve. So I differentiate the top, is going to give me 1 times I maintain the function, then I pick length of the base. So you see that because I've been doing it, I have it in my mind that differentiate the top, you get 1 times the whole of the function, then times the length of the base. So this one was simplified to 5x, the natural log of 5. Is that right? Then let's look at b prime. Now b prime, this one we need to use the idea from the previous video, right? So this one we need to use the change rule. So first the derivative will hit the sign, giving us cos of 2x times, then we differentiate what is inside, and then we are going to have 2. So this is going to give us 2 cos 2x. So now that we have a prime, b prime, we use the idea of the product rule to solve this. So a times b prime and then b times a prime. So finally, we can write our h prime of x to be equal to 5x times 2 cos 2x plus 5x natural log of 5 sine 2x. So what did I do? It's just this multiplied by this, and then this multiplied by that, and this is what you're going to get. So if I want to write this one nicely, I'm going to have something like 2 cos 2x 5 to the power x plus 5 to the power x ln 5. So let me just write the ln 5 last, then sine of 2x ln 5. So this is kind of very nice to write. So you see that because I know how to differentiate individual function, for example, x to the power 5 to the power x and then sine of 2x, knowing that this follows the product rule was not difficult, because knowing that, okay, I'm using the product rule is not just the final result, but how to differentiate them individual function is also very important. So know how to do the process. So if this is your first time and this is your first video that you are watching, go back, get some time and watch videos on how to differentiate exponential function using the change rule and stuff, and then you can continue from there. Let's talk about this one too again. Good. So this one too is still non-constant base, but this is very nice. So let's see what we can do here. So y to be equal to, let's say, k of x. So if I do that, then y will be equal to x sine x. So anytime you have something like this, you know what you are doing, right? So I pick natural log on both sides, sine x, and then this one will help me to bring down the sine and then have my ln x. So as I said, you see that this is going to give us 1 divided by y times y prime is equal to, then we use the product rule. So if I've done the product rule, if you've done the product rule, you'll be good. So here what I'm going to do is I'm just doing straight without picking A and B, right? But if you are no good, you can just go through picking A and B. So now I maintain sine x and differentiate ln x. What am I going to get? 1 over x plus, now I maintain ln x and differentiate sine x, which is going to give me cos x. So this is how I'm going to do the product rule. If I use this one and then using a prime and b prime too, you are going to see that you are going to get the same thing. So this is sine x, this is natural log of x, this is 1 over x, and this is cos s. So when I multiply this one by this, I have this one here. And then when I multiply this one by this, I have this one also here. So that is the product rule. So whilst you are learning, try and then figure out how you can also use the straightforward approach when you become very good, and then you will see that you will be okay. So here I'm multiplying through by y. So I multiply this one by y. I multiply this one by y to cancel it out, multiply by y. What is y? Y is this. So this is going to give us sine x sine x plus ln x cos of x all times x to the power sine x. So this is what you are going to get at the end of this video. So basically you see what we are trying to do here every day. Like, we are trying to make sure that we do this and we do it very well to get it done, right? So that is basically what we are doing here. Now let's look at the next question. Let's look at the next question. So what is the next question? Next question, we are going to use the quotient rule, right? Because we've learned the quotient rule. So quotient rule, we are saying that we have u divided by vn, right? So we can pick u to be e to the power 2x, and we can pick vn to be equal to 7 cos of x. So we need u prime. So how do we differentiate an exponential function? We differentiate what is on the top, we get 2, then we multiply by the whole of the function, right? So we differentiate the top. When you differentiate 2x, you get 2 times the function. Then this is vn prime. This is constant base function. So differentiate the top, the same thing, you get minus sine x. So I differentiate the top, I get minus sine x. Then I maintain the whole function times the whole function cos x times ln of the base. So this one we are not done. We need to multiply it by ln of the base. This one too, we can multiply by ln of the base, but this one is 1. So we don't need to do that. So this is what we are going to get at the end of the differentiation. So let's go through by writing down the formula for finding quotient rule. So vn u prime minus u vn prime divided by vn squared. So simplifying this, we are going to have something like this. This is going to give us vn is 7 cos s, u prime is 2e to the power 2x minus u is e to the power 2x, and then vn prime is minus sine x, 7 cos x natural log of 7, all divided by vn squared. So 7 cos x all squared. So if I want to do some small simplification here, I'm going to have something like 2 times 7 cos s e to the power 2x minus okay, so I think I can factor something out. I have this guy here, I have this guy also here, I can factor it out. So 7 cos s out, this one will be left with, or I can even factor the e2 out. I have this one here, I have this one too here, so let me factor it out. 2x. So here we'll be left with 2 plus, because this is minus, this is minus. So I factor this one out, I factor this one out. So it will be left with sine x natural log of 7 divided by, this means that we have it to be squared. So this is like 7 cos x, 7 cos s times 7 cos s, right? So that one of them will cancel this. So we are going to have something like this, e to the power 2x 2 plus sine x natural log of 7 divided by e to the power cos of x. So this is what you are going to get. So you see that knowing the quotient rule, if I know that this is the quotient rule, that's good. But we should be able to know how to differentiate the individual functions as we've grouped them into, okay, this is what I'm using and this is what I'm using. Now let's do f. F is constant base, right? So let's go through the process. So constant base, so gen prime of x is equal to, we need to differentiate what is on the top, which is cos squared 5x, times, we maintain the function cos squared 5x times length of the base. So we are done with the process. Differentiate what is on the top, which is here, multiply it by the whole function, then multiply by length of the base, and then you are there. So now what we need to worry about is how to differentiate this. Now I'll write this one as d over dx again. Now I need to write this one for you to see. So this is the same as cos 5x all to the power 2. So remember, when we are dealing with the change rule, we need to change this one before we can differentiate. Times cos 2x squared 5x times length of 2. So now let's differentiate. Let's use the power rule for change rule to do it first. So 2 down, cos 5x all squared minus 1. So we've used the power rule to work with this one without touching what is here. Now the next thing that we need to do is, now we need to differentiate what is inside the bracket. So what is inside the parenthesis here is this. So we need to differentiate cos of 5x. Now times cos squared 5x length of 2. So we are doing a lot here. So this is going to give us cos 5x. This one will be 1 times. Now when I differentiate cos, this one is also change rule again. So first the derivative will hit the cos. When I differentiate cos, what am I going to get? I'm going to have minus sine 5x times, then I differentiate what is inside the bracket. I'm going to have 5, then times cos squared x natural log of 2. Then our final simplification now will be, I have minus here, so I can factor it out. So I'm going to have minus 2 cos 5x sine. Okay, I have 5 also here, so I can multiply by this to get 10. So minus 10. Then this one will be sine 5x times cos squared x natural log of 2. So this is what you are going to get. So you see, I was just doing it step by step. I know what I'm using. And the first rule that I was using here was, I'm using the constant base. So I applied the constant base on this one. And when I was differentiating what is here, then I need to use the change rule. So you see that as we are going, we combine all the rules along as we are going. Yes. So that is basically what we are going to get from F. So we are done with non-constant base and constant base functions, right? So let's see where they are going to be. So constant base function is here. and then non-constant base function is also here. So we know that anytime you have a function which is like not a constant, we know how to differentiate. So you see that as we are going, we are adding up how many general rules with the formulas. These are 5 now, and this is like 8 now. So now I know that when I differentiate a constant, I get 0. When I differentiate a power rule, I know how to do it. I know how to differentiate exponential function. I know how to differentiate natural log function. I know how to differentiate log functions, trig functions, constant base function, and non-constant base function. So if I know how to do all these things together, then I don't have any problem again. In addition to this formulas, I know how to go with the chain rule. I know how to use the quotient rule, product rule, sum and difference rule, and then the constant rule, constant multiple rule. Combine this with this one. If you have them in mind, then you are the best person. You know, um, you are the one that you can do differentiation very, very, very well, right? And always I say that if you are very good with differentiation, integration will become a bonus. So please pay attention to whatever we are doing here and try to understand it, because when you are very good with this one, your integration, I'm not going to worry myself a lot because you are going to be very good with that one. Okay, let me show you the trial question that I want you to do. So I want you to do this and leave your final results in the comment section. Now, what we are going to do in the next video, we are going to talk about L'Hopital's rule. You know that when we started limit, we're supposed to do the L'Hopital rule, right? But the L'Hopital's rule goes with differentiation. So I was thinking of, okay, let's do differentiation and know how to differentiate the functions before now we talk about the L'Hopital rules. So in the next video, we are going to talk about L'Hopital rules before now we move to implicit differentiation, and then we move from there. So see you in the next video.